Bismillahirrahmanirrahim. Previously we talked about perpendicular bisectors and how perpendicular bisectors are concurrent, and the point of their concurrency is called the circumcenter. Now the circumcenter is the center of the circle that circumscribes a triangle, and the triangle is said to be inscribed in this circle. From the circumcenter to each of these vertices, that point is equidistant like this, and that's the radius of this circle that we form. Okay, and the circumcenter, of course, is the intersection of the perpendicular bisectors like this. Today I wanted to explore the point of intersection of the angle bisectors, and we have discussed previously that angle bisectors are also concurrent. So let's see what happens with the angle bisector. Maybe we'll discover a similar phenomenon that's curiously interesting. So I'm going to draw the first angle bisector here, okay, like this. Okay, ta-da. So I'm hoping that this is reasonably accurate. Now you realize, of course, that every point on this angle bisector, let's say that point right there, is equidistant from the sides of the angle like this. Okay, that's from the angle bisector theorem, correct? So every point on the angle bisector is equidistant from the sides of the angle. So there's one point, and if you wanted to explore, let's draw another point over here. This point is also going to be equidistant from both sides of this angle like this. Okay, now let's draw the second angle bisector and see what happens. So here it is. I'm going to pick this right here, start right here, and draw this point. Here we go. So that's our second angle bisector. I'm going to call it like this. And now you also realize that every point on this angle bisector is also equidistant from the sides of these of the angle. Okay, angle C, like this. Let's pick another point right here. That's going to be equidistant. These are perpendicular distances, of course, like that. Correct? Now every point, including the point of intersection of these two angle bisectors right here. So this point right here is going to be equidistant from this side, like this. Okay, so that's like this. And then it's going to be equidistant from this side, like this. Trying to make, there you go, like that. Okay? So it's going to be equidistant from those sides. Now let's draw the third angle bisector to complete our picture here. So here it is from vertex B or angle B, and it's going to be like this, and it's going to be concurrent. Now this point here that we have right here, this point of concurrency, is also very unique, because now you realize that this point is going to be equidistant from this side and this side, like this, and then it's going to be equidistant from this side too, like that. Correct? So this is going to be congruent to this. Now we realize then that this point is very special in that it is equidistant from every single side. Now I'd like you to observe. The point of concurrency of the perpendicular bisector was equidistant from every different vertex, like this. So the circumcenter was equidistant from every single vertex. On the other hand, this point right here, and we should give this a name, let's call that point P. This point here is the incenter. That's called the incenter, and is equidistant from all the sides of the triangle. So one is equidistant from all the vertices of the triangle, and this point, this particular point, is equidistant from all the sides from the angle bisector theorem. And this point is also super special, as you can imagine, because it is the center of a circle. What kind of a circle, you would say? I don't know. Let's find out. It is the center of a circle that's inside this triangle. Aha. Now watch. I'm going to try to color this circle. Okay, there we go. There we go. And there we have it. Let's try it. There we go. Now, the point of intersection, therefore, of the angle bisectors is concurrent, and it is the center of the circle that is inside this triangle, or the circle that's inscribed in the triangle. And this point of concurrency is called the incenter. It is the only point in the triangle that is able to do this. The circumcenter is the only point in the triangle that is able to circumscribe the circle around the triangle, and the incenter is the only point in the triangle that is able to inscribe a circle within the triangle. So I think that's pretty cool. The perpendicular bisectors give you the circumcenter. The angle bisectors give you the incenter. Until next time, as-salatu was-salamu ala rasulillah wa alhamdulillahi rabbil alameen. Assalamu alaikum.